So when you have similarity, what were the two things we discussed yesterday? What are the two main things that happen with similarity? What?
The scales are the same.
The scale factors are the same, what else? That's side length, what?
Their angles are the
Their
same.
angles are congruent. So scale factors are the same for the side lengths, so the lengths of the sides are not the same, their scale factor is, and the angles are congruent. So here you have similar polygons, and we're gonna talk about circles too, because that's gonna be a little bit different. So if I have similar polygons, okay, and it says polygon ABCD is similar to EFGH, okay? Tell me what I know about these two things. What can I automatically know? What's congruent, what's what? Okay, so angle D and angle H, you wanna say, are congruent. That is true. What else? Angle D, angle H, what else?
Angle,
What?
angle A and angle E.
Angle A and angle E, good.
Angle B and
Angle B and F, and C and G. Okay. Angle B, and angle F, and then angle C is congruent to angle G. What else could I set up from this information?
No.
What? What do you mean? So, line AB and line EF. They're not congruent. They're similar. What is that called when I set it up to show similarity? You have to set it up in a, yes, Carly, in a proportion. Okay? So I know that AB, well actually, we're gonna pretend that this is our original. So I know that EF over AB equals what?
Those are
It does, but what other sides could it be, what else could it be equal to? Okay, what? HG over DC, okay, what else? What else would all those be equal to? FG over BC, okay? And the last one would be what? Yeah, EH over AD. Okay, so when I am dealing with similar polygons, the same rules still apply as they do to triangles, okay? My angles are all still congruent, and my sides still set up proportions, okay? The fun thing about polygons is I can divide them into triangles also. And I'll be able to start solving some stuff, which is where Bryson's gonna come in a minute. Okay? He was all part of the lesson plan. Okay. So it says similar polygons and circles. Okay, circles are always similar. Okay? I don't know why my computer did this. I'll move that up in a second. Okay. So similar polygons and circles. Circles are always similar, period. They're always similar. Okay? The only time you have a congruent circle is if it's exactly the same. Otherwise, I have bigger and smaller circles. So they're always similar. Okay? Angles are congruent because circles, do they have angles?
No.
No, but what is the technical angle of all circles? 360. So my circles are similar because no matter what, a circle equals 360 degrees. Okay? Now this is where it's a little bit different. All the lengths are proportional, okay, which is what we're used to. Whoa, what we're used to. But the lengths in this case are the radii and the circumference, which means the radius and the circumferences are proportional. Okay? So when circles are similar, okay, they have the same angle, which is true, it's all 360, but the radius and the diameters are what's proportionable now. The radius and the circumference is what's proportional now. Well, the diameter would be too, because the diameter is half the radius, or the radius is half the diameter. Okay? So all of those portions are, what makes circles similar, okay? So then, you have this, okay? Similar polygons and circles. Circles are always similar, so in this case, these are two similar circles, okay? What would be the proportion of these circles? Let's say we go left to right. 2 to 4, okay? 2 to 4, which means what would that be? Which would reduce down to 1/2. So this circumference is going to be 1/2 of this large circle's circumference, okay? This radius is going to be 1/2 of this radius, and the diameter is 1/2 of this overall diameter. Okay, so circles still have the same rules applied to them too. You just have to realize the angles are always 360. That should be an easy thing for you. And that the radius and the circumference are what we're comparing in proportion. Okay, radius and circumference is what you're comparing in proportion. You having fun there? Okay, similar polygons. So, other things that are similar. The two rectangular swimming pools are similar, okay? How far is it diagonally across each pool? Okay, if these are similar, I can set up a few things and solve, or I can use something else. There's two different ways I can solve this, depends how you look at it. What's one way? What? Can you do what? Area? I could use area, it's gonna take longer, so there's maybe 3 ways I can solve this. If I know they are, the two rectangular swimming pools are similar, what do I know about them? Their angles are the same, and what else? The center dilation, what else? This is a circle, it's not a circle. The angles are the same, we've got that down. What about the side lengths?
They're similar.
They're similar, which means I set up a proportion. What proportion could I set up to solve for this?
15 over 20 equals 12.
Can you set up? Okay, you said 15 what?
15 over 20 equals 12 over 16.
Okay, that would tell what those sides are. The problem is, I need to know what this is, and I need to know what this is.
Oh, this is the hypothesis.
Okay, so 15 over 12, yes, we're gonna talk about that in 1 second, Bryson. 15 over 12 equals what, Carly? Yeah, something like that, but here's the problem. If I wanted to set up a proportion to solve this other side, right, it would have to say this. Well, now I have 2 unknowns. That's not possible, right? Currently, we don't know how to do that. So, Bryson's correct. Look at this. This makes a what type of triangle? A right angle. So I can use something called the Pythagorean theorem.
C squared.
Okay, what is it?
A squared plus B squared equals C squared.
Good. A squared plus B squared equals C squared. C squared is always your what?
Answer.
C squared is always a specific part of the triangle. It's the hypotenuse. Yes, it's the hypotenuse. So my C squared in this case is my X or my Y. Okay, so I'm going to set this one up to say 15 squared plus 20 squared equals C squared. What is 15 squared?
225.
225? What?
Good job, Bryson.
And what is 20 squared? 400. So 200 plus 400 equals C squared. What is 225 plus 400? And 625 equals C squared, so then what do you have to do?
Then you have to divide. I mean, no, you have to take the square root.
Take the square root, and C would equal, I think it's a perfect square, is it 25?
I'm going to say it's 25.
So this equals 25. So now that I've done that, now instead of doing Pythagorean theorem for the next one, can we just set up a proportion?
Yes.
and save some time.
Yes.
Okay, so on these type of problems, you're going to have two steps. You're going to have to set up Pythagorean theorem and solve for one side, and then you can set up a proportion, make it a little bit simpler and a little bit quicker. Okay, so then if I want to solve for y, I'm now going to say, Carly, 15 over 25 equals 12 over y. So I get 15y equals, what's 12 times 25?
30.
12 times 25.
I got this.
It's what? 350.
325. 75.
Remember that.
It's in the threes, right?
It's real low in the threes.
Yeah,
Real
right.
high.
300.
300. Oh my gosh, so close. Now, what happens when you divide 300 by 15?
You get 20.
You get 20. So look at this. Let's compare proportions now and make sure we did this right. 20 over 25 reduces down to what?
Wait, what are we doing?
4 fifths, right? 4 fifths. What does 12 over 15 reduce down to?
3/4. Wait, hold up. 4/5.
4 fifths. Okay. And then we just got to triple check because I'm crazy like that. What's 16 over 20 reduce down to?
4 fifths.
4 fifths. So we did our math right, and that's how you can check your math to make sure all the proportions are still the same. Okay? So Pythagorean theorem, then set up a proportion and solve for your unknowns. When you have two unknowns. I put them on after I teach 6-bell. Okay. The CCS Junior High wants to build a basketball court that is similar to the high school basketball court, which are 84 feet by 50 feet. 84 by 50, okay? However, the junior high only has room for a court that is 42 feet wide. How long should the court be to the nearest foot? I know, I only had squares, I didn't have rectangles to work with, so you get to deal with it. Just try to give you a visual. So how can I set up something and figure that out? What do I need to do? What do you think I need to do? Okay, set up what? Set up a proportion. What proportion am I gonna set up? I don't need to know the diagonal of this, so there's no reason to figure out this. What?
50 over 84.
You wanna say 50 over 84? Okay, so 50 over 84, and then what?
42.
Equals what? 42 over x. Okay, what's x? X and 50 is 50x. Oh, thank you, that was a hard one.
I know.
What's 84 times 42?
3,528.
3,528.
Bryson, be quiet.
That's a large number.
Yeah, 3,000.
No, it's not. 84 times 42, yes. 3,528, and then I have to take this and I have to divide by 50.
70 by 56.
Just start by thank you. And you get what?
70 by 56.
And they said round to the nearest foot, so 71 feet. Okay, so 71 feet. How long should the court be to the nearest foot? 71 feet. That's all you have to do. Okay? I don't know why this is like so large today. Okay, let's do this. So this is the polygon area theorem, okay? And it says if two polygons are similar, then the ratio of their areas is equal to the ratio of the squared lengths of any pair of the corresponding sides. So what it's saying is, if I take the area of this large one, and then I take the area of this small one, I can set them equal to the square of the proportions of these two sides. So you know how like AB over EF equals BC over FG? Yes, like my sides set up as a proportion. If I square those proportions, it will equal the area ratio. Okay, but there's a reason we gotta figure that out. And I'm gonna tell you why here in a second. I'm gonna make this smaller so that it'll fit on
Oh, because, I understand
my board. Okay?
why it's square,
So it's
Why it's square?
diagonal.
because it's a triangle.
Yes.
You put
Oh,
two
we're
of them
talking about
together.
triangles?
We're talking about polygons, any type of shape of a polygon, okay? So it says, what is the area of triangle XYZ? It says triangle FMN is similar to triangle XYZ, okay? So, according to my similar polygons theorem, okay? It says that two polygons are similar, then the ratio of their areas is equal to the ratio of the squared lengths of any pair of corresponding sides. So what could I set up to solve for this? Oh. Got an idea?
72 over. Is it here? 72 over the area.
Okay, 72 over the area, okay, and then what? Equals. And it says it's the ratio of the squared lengths of any pair of corresponding sides.
12 over 9.
Not 12 over 9.
9 over 12.
It's the squared,
12 squared over 9 squared.
12 squared
Oh.
over 9 squared.
I thought you
Okay.
were something.
So it's the,
Really?
so it's the squared length of that, okay? So if it's the squared length, that's where we have to remember, because a lot of times we just set up the proportion, we forget to square it, and that's gonna change your answer. So 12 squared is 144, I know that, so I have 144A equals 9 squared is 81, so what's 81 times 72? What is 81 times 72?
Oh, sorry.
5,832.
5,832, thank you. And then I'm going to take that and divide it by 144, and you would get A equals,
Big number, I guess.
40.5.
you get A equals 40.5. Okay, 40.5. A equals 40.5. So this area here is 40.5. And if I check out the proportions, okay, it would be 72 divided by 40.5, which would give me 1.8 or something like that. And then it would be 144, the 12 squared divided by the 9 squared, which gives me 1.8 also. So my proportions are correct. A photographer wants to shrink a rectangular mural that is 120 inches by 40 inches. So if I have this mural, it's 120 by 40.
That is beautiful.
I know, right? This is how I do math.
Can you make
To a similarly shaped photograph, I should say photograph, to a similarly shaped photograph with an area of 75 square inches. So it says this other one has an area of 75 square inches. Okay? What will the height of the photograph be? Can I figure out what the area is of the other one? How? 40 times 120, so sometimes we just have to use our brain a little. 40 times 120. This area is 4,800, right? Okay, so if this area is 4,800, my rule says that the area's proportions equal the squares of any two proportional sides, right?
Yes.
And I want to find the height, right? It says a mural that is 120 inches by 40 inches, so 40 over x. 40 squared, good Kayla, over x squared. So you get 4,800 x squared equals whatever 40 squared is, which is 1,600 times 75, which is 120,000. You're gonna divide it by 48,000. I gave too many zeros on that.
That's a lot of zeros.
So how is it 10?
I mean, chemistry.
Oh, the line is so good.
Shut up, Kayla. Divided by
25.
4,800.
25.
25, so then you have x squared equals 25. Then you have to take the
Square root.
and x would equal, so your height of your new one is 5.
Yes.
Okay.